Proud to present its new high productivity model of automated multi-station forming machines, a state-of-the-art double-end metal tube forming system. The system was created in response to the automotive industry's ever-growing need for high technology in the production of drive shafts. The AM-SFM40 transforms a raw metal tube into a highly accurate finished product. The fine precision of this machine assures the highest quality in each and every piece produced, no matter what the production volume. This system is built by Torrington, Swager & Vale, a company whose engineering expertise has been at the leading edge of industrial high technology for almost 100 years. Torrington, Swager & Vale conceived, designed, and developed the automated multi-station forming machine and other custom-made machinery in response to a wide variety of industrial applications. If you're searching for ways to improve efficiency and cut production costs while achieving greater precision with unfailing consistency, this system is the answer. The automated multi-station forming machine, or AM-SFM40, presented here is an integrated computer-controlled system that is hydraulically and pneumatically driven. It can form up to 28 inches of overall tubing length, producing a higher quality product than any other system. Basic components include a feeder station and 4 workstations with an ejection system, each station performing a separate function. Any one of the forming stations can be bypassed or repositioned to suit the needs of any particular kind of work. The system has remarkable flexibility and versatility, one of its great advantages. The machine is fully automatic, but for setup purposes, it can be set to manual mode. The system processes 2 parts at a time. The double loader that receives the blanks is equipped with a gauging system that automatically measures all blanks and stops the machine when an out-of-tolerance blank is detected. Additional airproof systems assure that correct blanks of proper diameter and wall thickness are loaded into the feeder. An additional tool error-proof system identifies the dies and stripper stops at each location on the machine. If at any time a die or stripper stop do not correspond with the pre-programmed requirement, an alarm will indicate that on the main monitor screen. The machine-accepted blanks are loaded into the walking beam that transfer them to the first working station. In the production process shown here, the AM-SFM40 performs the following sequence of events: carrier side and flange side reduction, carrier side sizing, and flange side double reduction. The parts are moved from one station to the next by a walking beam. On the first forming station, a 3 3/4 inch long carrier side reduction and 4 3/4 inch long flange side reduction are formed. Both ends are formed at the same time. The walking beam mechanism transfers the part to the next forming station. The second forming station produces a double reduction on the flange side, holding the carrier side on the opposite end. This guarantees great concentricity between the 2 formed ends throughout the process. The advantage of this forming method is that it minimizes the cycle time, assuring greater concentricity between the 2 formed ends while reducing the number of machine stations. This principle is yet another example proving that Torrington, Swager & Vale always strives to be at the leading edge in the development and application of state-of-the-art technology for our clients' benefit. Prior to the forming operations, both ends of the part are lubricated with oil, provided from a central recycling system, a system that respects the environment and the need for conservation. The system produces 2 parts at the same time, one left hand and one right hand. So far, we've shown you the forming process for the left hand part. The same forming cycle is followed for the right hand part on the succeeding 2 stations. At the end of the process, the parts are ejected and sent to washing operations. The machine can be programmed for up to 9 types of parts. The changeover from one part to another is minimal and can be accomplished in less than 20 minutes. An overhead hoist system facilitates this operation throughout the machine areas. Special attention was paid to safety and ergonomic factors. All work areas with moving parts are protected by a local physical barrier and a surrounding fence barrier. However, the system allows great accessibility for setup and maintenance. The main operator interface is mounted at the loading area. In addition, each station has its own operator panel control for manual operation and auto test, facilitating operator access to the machine's controls from almost any location around the system. The monitoring graphics are user-friendly and all operations can be followed continuously. That completes the process from raw tube to finished part, quickly, efficiently, precisely, and to the highest standards in each and every step for each and every part. The AM-SFM 40 is designed and built to produce parts well within SPC quality control requirements applied in the automotive industry, that is, dimensions well within CPK 1.81. The AM-SFM 40 generates a very high production rate due to the simultaneous nature of the operations that take only a few seconds each. For this application, the production rate is 200 pairs per hour. Using the AM-SFM 40 results in lower production costs with reduced manpower and waste. Only one operator is needed to load the feeder. Costly human error is avoided, but flexibility is retained and greater precision is taken for granted. The key to the continuous success of any company is its ability to design, develop, and engineer a constantly improving product. For almost 100 years, Torrington, Swager, and Vail have had that reputation, a reputation for excellence and reliability.